Hello friends, I am Shivkanya and guys you are welcome to the Physics Warrior by Shivkanya YouTube channel. Guys, this is the sixth lecture on the elasticity topic series. This topic series is useful to 12th board examination, JEE, CET, NEET and also useful for the other entrance examinations. In the sixth lecture on the elasticity topic series, we are going to study firstly behavior of a metal wire under the increasing load, and next of that strain energy or elastic energy. So without wasting a single minute, we will start today's lecture. Guys, until now we have studied about the determination of Young's modulus of a material of a wire, and for that we have find out this formula, that is formula number 14. Okay, and now we are going to study about behavior of a metal wire under the increasing load. Guys, the behavior of a metal wire subjected to the increasing load can be studied by using Seals method. With the help of Seals method, we can study behavior of a metal wire under the increasing load or gradually increasing load. And in this case, we are applying a load to the free end of that wire in the steps of half kilogram until the wire breaks. Guys, that is, जब तक हमारा वायर ब्रेक नहीं होगा तब तक हम हाफ किलोग्राम के सेंस से हाफ किलोग्राम ऐसे लोड दैट इज वेट बढ़ाते रहेंगे एट द फ्री एंड ऑफ दैट मेटल वायर. एंड ड्यू टू दैट एडिंग हाफ किलोग्राम weight to the one free end of that wire, it gets elongation in the wire, and that elongation in the wire we are measuring. I will explain you how elongation in the wire we will get by adding the weight or load on the free end of that wire. Let's see. I will explain firstly. I will take a rigid support here. This is a rigid support. This is support, and one wire is freely suspended to this rigid support. This is a wire, and if we are adding some weight to the free end of this wire here, then what will happen with this wire? We know that wire will be some elongation in the downward direction ना. Suppose हम वायर के इस फ्री एंड को some weight अटैच कर रहे, मतलब उसे फोर्स अप्लाई कर रहे, then due to this force इस वायर की लेंथ में elongation क्रिएट हो जाएगा. Again some time after we are adding some weight here. जैसे मैंने बताया था हाफ किलोग्राम ऐसे हम वेट बढ़ाते जाएंगे एट द फ्री एंड ऑफ दैट वायर. देन क्या होगा, when we are applying again weight on the free end of this wire, then we get some more elongation in the length of this wire. See here, जब हम इस फ्री एंड को वेट अप्लाई कर रहे हैं तो हमें elongation मिल रहा है. And again we are adding some more weight here. It will be elongated more and more na. See this. This is a more elongation. This elongation occurs due to by adding load on the free end of this wire. जितना हम लोड बढ़ाएंगे उतना ही इस वायर की लेंथ में elongation हो रहा है. If gradually the load is increasing, then how can the wire behaves? That can be explained by using this concept, and we are going to study this. Actually, I am saying that if we are adding some weight here, or if some load is attached to here on the free end of this wire, then some elongation created in the length of this wire ना. We remove this weight जो हमने firstly weight add किया था, वो लोड हम remove कर रहे, then the wire gets its original position or original length, which can say that the elastic nature ना. And if we add some more weight again to this free end of that wire, it also gives some more elongation. जितना हम weight that is load बढ़ा रहे at the free end of this wire, we are getting corresponding elongation in that wire. Second time में हम जितना weight add किए वो weight हम remove करें तो वो हमारा wire फिर उसकी original position में आ जाएगा. That is also elastic nature. That means up to a certain weight it will regain its original length. That can be said proportionality na. Means here Hooke's law obeying. Here in this nature or in this region Hooke's law works good. Guys, here we applying load or weight, it means that we applying stress here. Guys, now we applying load means we applying a stress here. Load in the sense of weight, and that weight is in the form of stress, here we adding. And वायर में जो लेंथ में बदलाव आ रहा है, that is the elongation. Elongation in the wire means the wire thinning and thinning means elongation in the wire means it will elongate or it will indicate that the strain in that wire. This elongation is nothing but the strain. How much strain in that wire due to the applied load or weight. Guys, if once we adding some more weight on the free end of this metal wire, then the wire get elongates. If we remove this weight, it doesn't regain its original position or original length. That means it has some elastic nature, but it doesn't obey Hooke's law. Can you tell me why this doesn't obey Hooke's law? Because हमने इलास्टिक लिमिट के ऊपर कहीं वेट ऐड किया है. That's why हमारा Hooke's law obeys नहीं कर रहा है. Actually, we know that the definition of Hooke's law. Within an elastic limit, stress is directly proportional to the strain. Within an elastic limit, it is the most important sentence ना. But हम क्या कर रहे हैं इस केस में? After the elastic limit, we applying a load. That time, our wire get elongated, but it doesn't regain its original position. So that our Hooke's law not works good here. See later, the wire will be yielding. Yielding in the sense, yielding means thinning and thinning. Yield होना मतलब वो जो वायर है मेटल वायर उसकी लेंथ थिन हो रही है. That is the yielding. Yielding nothing but the thinning process. That is, if we adding some more weight here, then our wire will get thin and thin. वो thin and thin हो जाएगा. Why it get thin and thin? Due to the applying load or that applying weight. In this way, if we adding unbalanced load or unbalanced weight, that time at a particular point, this wire will be ready to break. Once, if we add or without adding the weight, automatically the wire breaks. Means वायर के फ्री एंड को हम वेट ऐड कर रहे या नहीं कर रहे ये मैटर नहीं करेगा, बट हमारा वायर डेफिनेटली ब्रेक होगा. देन कैन यू टेल मी व्हाई वायर ब्रेक्स? ओके, आई विल टेल यू. Wire breaks because we have added too much weight above its elastic limit. So that wire breaks. Next, what is the use of knowing this behavior of a metal wire under the gradually increasing load? इस कंसेप्ट का यूज क्या होगा हमें, ये हम नेक्स्ट स्लाइड में देखेंगे एंड आई विल एक्सप्लेन पॉइंट बाय पॉइंट. सी केयरफुली गाइस, दिस इज अ ग्राफ ऑफ स्ट्रेस वर्सेस स्ट्रेन. On the y-axis, we have taken tensile stress. This is our x-axis and this is our y-axis. In this graph, the region from point O to E is directly proportional to both axes. Now, means in this region, stress is directly proportional to the strain. That is nothing but in this region, Hooke's law obeying up to point E. So, point E is nothing but the elastic point. जहाँ तक हमारा इलास्टिक लिमिट ओबेज हो रहा है मीन्स जहाँ तक जिस पॉइंट तक हमारा स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू द स्ट्रेन, दैट इज हुक्स लॉ ओबेज हो रहा है, दैट पॉइंट इज नथिंग बट द लिमिटिंग पॉइंट. एंड पॉइंट पी प्रोपोर्शनल पॉइंट. व्हाई पी इज द प्रोपोर्शनल पॉइंट? बिकॉज अप टू दिस पॉइंट our stress is directly proportional to the strain, so that our P point is the proportional point. Are you getting this? See, these are the notation which are used in that graph. E is the elastic limit and OS is a permanent set. Then YP is showing the yielding point. Yielding is nothing but the thinning process. Wire की length thin होती जा रही है. N shows the breaking stress and last B shows the breaking point. Now we are going toward the explanation. Initially our point is O, which is at the origin. Then OE is the straight line. Na? See in the graph. This OE is a straight line. If this black line is visible to you, I have drawn, which shows the stress is directly proportional to the strain. Already I have explained. That means Hooke's law obeying point up to E. The value of stress corresponding to the point V is called as the elastic limit of that material wire. A point E जो है वो elastic limit वाला point है and वो जो P point है वो proportionality point है. If we remove the applied load to the wire completely regains its original position or original length. So the point E represents the limiting point of proportionality between stress and strain. I have explained ना. वेट ऐड करें तब हमारा आफ्टर रिमूवल ऑफ द वेट वो वायर इट्स की ओरिजिनल पोजीशन रिगेन कर रहा था. देन यहाँ तक वो उसकी पोजीशन रिगेन करेगा. मीन्स इस रीजन में हमारा स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू द स्ट्रेन है. ओके, नेक्स्ट फ्रॉम द ग्राफ, इफ वी एड सम मोर वेट हियर, it doesn't get its original position, but it have elastic nature na. See here, but it have elastic limit, but it have elastic nature up to point E dash. Up to point E dash, it has a elastic limit which can be explained by term E dash. And from point P to E, the graph, when load is removed, the wire regains its original position or original length, but stress is not directly proportional to the strain. See here, only point E, our stress is directly proportional to the strain, but E point में भी हमारा elongation हो रहा है आफ्टर एडिंग द वेट. बट जब हम वो वेट रिमूव करेंगे तो हमारा वायर उसकी ओरिजिनल पोजीशन रिगेन नहीं कर रहा है. Why this wire doesn't regaining its original length? See here, this is a neck like structure ना. ये डायरेक्टली प्रोपोर्शनल तो नहीं है, ये लाइन स्ट्रेट लाइन नहीं है, दैट इज नेक. मीन्स आवर हुक्स आर नॉट वर्किंग हियर इन दिस रीजन P to E dash, so that wire doesn't occupy its original position or original length. Are you getting this? It's a very simple point. It means here Hooke's law doesn't work and point E is called as the elastic limit, and stress is not directly proportional to the strain, and Hooke's law doesn't obey. Now we are going to discuss what is a permanent set. This जो distance है O to S, that distance is nothing but the permanent set. Later from the diagram E to B, see this portion E to B, ये जितना portion है, ये जितना region है, from the diagram E to B, load is applied on the wire is removed. The wire doesn't regain its original or natural position, that is, so it will have a permanent increase in the length, that is shown by the dashes line. A dash dash line से हमने denote किया है, that is over dash, which we can call it is as permanent set. So we will get the point number 3, that is called as permanent set region or permanent point. This region OS is called as a permanent point. So region between O and S point, that region is called as permanent set. Listen carefully, I will repeat again. Later from the diagram E to B, load is applied on the wire is removed. The wire doesn't get its original length or original position completely, so it will have a permanent increase in its original length, that's shown by this dashes line, that is a over dashes line, which we can call permanent set. So this point or this region is called as a permanent set. It's a very simple now. Here I have mentioned that why we call this the permanent set, and the strain associated this is OS, that is permanently in the wire. Okay, next is fourth point coming, that is yielding point. I will explain by using the help of this diagram or graph. When the wire crosses point E dash, strain, that is elongation created in the wire, increases rapidly without increasing by the load. So behind the point E dash, the wire becomes thin and thin. Hence point YP is called as yielding point. Means when we cross this point E dash, there is a more increment in the length of that wire. Behind point E dash, the wire becomes thin and thin. हमारा वायर पतला हो जा रहा है, उसकी थिनिंग बढ़ रही है. So that point YP is called as yielding point. Yielding is nothing but the getting thinning and thinning. From this, The stress corresponding to the point N is called as a tensile strain. N point के corresponding जो stress है उसे हम tensile strain कहेंगे because on the x-axis we have taken strain. So N is our tensile point. What is the tensile point? Because stress corresponding to the point N is the tensile strain. So point N is nothing but tensile point. Can you define the tensile strain? Okay, I will tell you. Tensile strain, it is a ratio of maximum load to that of original area of a cross section. It is a ratio of maximum load to that of original area of a cross section. See here, that is E dash point. There is elongation without increasing load. So behind the point E dash, wire becomes thin, thin and thin. Hence, point YP is the yielding point. The value of stress corresponding to the yielding point, that is yielding stress. I have already explained what is N point. N point is a tensile stress. The tensile stress is the ratio of maximum load to that of original area of a cross section. And point N is called as tensile point or breaking stress. Until now we have studied fifth point, and last point is the breaking point. See in graph, this is the point B, which is the last point in the graph. That B point is the breaking point. Guys, behind the point B, the thinning of the wire is no worse, means behind the point B, the thinning of the wire is no longer uniform and wire shows necks. Wire shows necks. वो स्ट्रेन की और खींच रहा है. And the point B, the wire shows the necks. At point B, wire also can break. So the point B is called as a breaking point. I will repeat this, guys. Behind the point B के बाद thinning of the wire no longer uniform after increasing or without increasing the load. Doesn't matter हम लोड अप्लाई कर रहे हैं या ना कर रहे हैं, क्या होगा, थिनिंग प्रोसेस बढ़ती जा रही है. एंड वायर शोज द नेक्स. ये जो नेक है उसे, ये जो कर्व टाइप है उसे नेक बोल रहे हैं हम. वायर शोज द नेक्स एट पॉइंट बी. वायर आल्सो कैन ब्रेक्स. So that point B is called as the breaking point. Until now, I have explained about stress and behavior of a metal wire under the increasing load और gradually increasing load. जैसे हमने बताया था कि हम हाफ किलोग्राम ऐसा लोड बढ़ाएंगे at the free end of the metal wire. सेम वैसा ही कंसेप्ट लगा के हमने एक ग्राफ ड्रॉ किया है. एंड इसका हमने all points, that is point P, E, E dash, Y, P, N, B point, all point physical significance भी देखा है. Now I will ask you one question. What is the use by knowing the behavior of this method? What is importance of this method? Why we are studying this method? I will explain you little bit. What is the use of knowing about the behavior of a metal wire under the increasing load? Then you should write this answer. By knowing this method, we are going to measuring the elongation created in the wire, and we are knowing about the types of metals or types of material like brittle metals and ductile metals. Okay, do you know about what is a brittle? I will tell you from the graph. If the plastic region from point E dash to N is large, the material is said to be a ductile. See here, point E dash to N, ये दूरी जितनी बढ़ेगी उतनी डक्टिलिटी बढ़ेगी. तो ये जो डिस्टेंस है E to N, वो जितना बड़ा रहेगा वहाँ हमें डक्टाइल मटेरियल फॉर्म होगा. एंड if the material breaks soon after the elastic limit cross, the material is called as brittle material. वो मेटल इलास्टिक लिमिट क्रॉस करेगा एंड टूट जाएगा, ब्रेक हो जाएगा. दैट मेटल इज कॉल्ड एज ब्रिटल. ब्रिटल नथिंग बट द ब्रेक, जल्दी ब्रेक हो जाएगा. सी हियर, आफ्टर द इलास्टिक लिमिट ई डैश, पॉइंट बी के बाद हमारा मेटल ब्रेक हो जाएगा. एंड आफ्टर दैट पॉइंट जो मेटल्स हमें मिलेंगे, जो मटेरियल हमें फॉर्म होगा, दैट मटेरियल्स और मेटल इज कॉल्ड एज ब्रिटल मटेरियल्स. बाय द हेल्प ऑफ दिस बिहेवियर ऑफ मटेरियल ऑफ अ वायर, we are getting two types of metal, that is brittle metal and second one is a ductile metal. Then question arises like, what are the examples of brittle metal and what are the examples of ductile metals? See, brittle metals is nothing but the which can easily breakable, जल्दी break हो जाएगी. just like ceramic, glass. These come under the brittle metals. सी जब ग्लास ऊंची से नीचे हम फेंक देंगे तो वो जल्दी टूट जाएगा. सेम लाइक सिरेमिक्स का कप होगा. कप हम थोड़ी ऊंची से फेंक देंगे नीचे तो जल्दी क्रैक हो जाएगा, उसे क्रैक पड़ेंगे. सेम लाइक ग्लास. तो these are the brittle materials. And ductile materials, says ductile. Tiles means or tiles are the similar terms. We can say tile or tiles that which elongates or more thinning. We can increasing length up to thinning and more thinning. Ductile is just like gold, copper, steel, iron, lead. गोल्ड को हम ऐसे फोर्स लगाएंगे और उसे खींचेंगे तो वो जल्दी टूट नहीं जाएगा, बिकॉज गोल्ड हैव डक्टाइल प्रॉपर्टी. सेम लाइक कॉपर, स्टील, आयरन, एल्यूमिनियम, दैट आर द डक्टाइल मटेरियल्स, बिकॉज ये जल्दी टूट नहीं जाएंगे. हम उसे लोड अप्लाई करेंगे, ऐसे उसे खींचेंगे स्टील को, कॉपर को और इन्हीं अदर डक्टाइल मटेरियल को, तो उसकी लेंथ में इंक्रीमेंट होगा, इलोंगेशन क्रिएट होगा. दैट इज द ductile materials. In short, by using this concept of behavior of a metal wire under increasing or gradually increasing load, we can design which metal is used for the which purpose. Remember this, by using this method, behavior of metal wire under the gradually increasing load, we can decide or we can design which metal is used for the which purpose. According to this, we will use that metals in a particular work or particular field. Okay, guys, until now we have completed the behavior of a metal wire under the increasing or gradually increasing load. I hope you getting this point. It's a very important point according to the your exam, because एग्जाम में ऐसे भी क्वेश्चन आ सकते हैं जैसे कि MCQ में व्हाट इज इलास्टिक लिमिट, what is the proportionality constant, what is the yielding point, tensile point, examples of breaking materials, ductile materials. and आपके theoretical एग्जाम में, यूनिवर्सिटी के एग्जाम में, आपके BSc 11-12 के theoretical एग्जाम में भी एक क्वेश्चन आ सकता है, यूज ऑफ बिहेवियर ऑफ अ मेटल वायर अंडर द इंक्रीजिंग लोड एंड कंसेप्ट बिहाइंड द बिहेवियर ऑफ मेटल वायर अंडर द इंक्रीजिंग लोड. होप यू गाइज prepare this point. All the best to you. Guys, from this table, we can see the approximate breaking stress of a material for material like aluminum, brass, glass, iron, etc. And in this column, I have mentioned the corresponding breaking stress for that material. And our breaking stress having unit Newton per meter square, because we know that unit of the stress, that is Newton per meter square or Pascal. Okay. Now we are going to next point, and that point is elastic energy or strain energy. Let us consider we are taking a wire of original length L and radius small r, which is suspended from the rigid support. Let's see, I am drawing this diagram. This is our support and this is a wire having original length capital L. See, this is the original length capital L, and this is the diameter of this metal wire, and we need the radius. Radius is nothing but the diameter divided by 2 is equal to radius, and its radius is small r. Okay, this metal wire which is suspended by the rigid support, this is our rigid support, and this is the free end of this metal wire. On this free end of the metal wire, we are applying some force or weight in the form of F is equal to mg. Okay, after applying the force, what will be the change in length of wire? It means that due to applied force, what will be the elongation created in the length? Guys, after applying the load on this free end of the metal wire, how the metal wire length increases, how the elongation forms, that things we have studied in the previous lecture on this elasticity topic series. If you have not watched that lecture on the elasticity topic series, please watch that starting lectures also, because introductory lectures playing major and more important role to understanding the elasticity chapter. Okay, this is our original wire having length capital L and radius r. Now on this free end of the metal wire, we are applying some force, that is load F is equal to mg. Okay. After applying some force, there is a increment in the length due to that applied force. See, this is our original length up to this, and when we applied a force here, that is F is equal to mg on that free end of the metal wire, then due to this applied force, there will be the elongation in the length of original wire, that is x. This x is nothing but the elongation created in the original length of wire. After this, again we applying some load on this free end of this metal wire, और हम इस मेटल वायर को थोड़ा सा खींच रहे हैं, मीन्स वी अप्लाइंग सम फोर्स हियर आल्सो अगेन, and due to this applied force our wire length increases. Let's see how wire length increases. Again, after applying the force, I will draw next diagram. Please see this. This is the support and this is our metal wire of original length L. हमने F इज इक्वल टू एम जी फोर्स यहाँ अप्लाई किया था, तो हमारी लेंथ थोड़ा सा इंक्रीमेंट हुई थी, दैट इज एक्स इतना इंक्रीमेंट हुआ था, बट आफ्टर एक्स इंक्रीमेंट होने के बाद और हम थोड़ा सा फोर्स इसे अप्लाई कर रहे इस वायर को, तो और थोड़ा खींचा जाएगा ना हमारा वायर. आई एम ड्रॉइंग दिस. सी हियर, आफ्टर अप्लाइंग फोर्स एफ इज इक्वल टू एम जी, हमारा वायर लेंथ इतनी थी, एंड अगेन यहाँ हमने जब एफ इज इक्वल टू एम जी फोर्स अप्लाई किया, थोड़ी देर बाद थोड़ा सा फोर्स अप्लाई किया, तो हमारा वायर और इंक्रीमेंट हुआ इतना सा. ओके ना, मीन्स हमारा ओरिजिनल वायर की लेंथ एल थी, आफ्टर अप्लाइंग सम फोर्स इट बिकम्स एक्स, एंड आफ्टर अगेन अप्लाइंग सम फोर्स इट बिकम्स डी एक्स. ये हमारा डी एक्स लेंथ है, एक्स टू यहाँ तक का, बट वी कैन नोटेड दैट this elongation, this distance is nothing but small l. Small l is nothing but created extension in the original length of wire. See here, ये जो यहाँ से यहाँ तक जो है elongation created in the wire, that is small l, means x plus dx is equal to small l. ये तो elongation है ना, जो हमने फोर्स अप्लाई करने के बाद अप्लाइड फोर्स की वजह से हमारा वायर की लेंथ इंक्रीज हुई, and that increment in the length of wire is nothing but elongation, and that elongation is denoted by small l, and original length is l. okay, मतलब जैसे जैसे हम थोड़ा थोड़ा फोर्स स्लोली फ्री एंड को लगा के खींच रहे, तो हमारा वायर थोड़ा थोड़ा इलोंगेट्स हो रहा है, मीन्स वायर की लेंथ बढ़ रही है ड्यू टू अप्लाइड फोर्स. एंड यहाँ जो एनर्जी क्रिएट हो रही है ड्यू टू स्ट्रेचिंग और ड्यू टू खींचने से, that energy in the form of potential energy. Okay guys, here we are applying force on the free end of this metal wire, means our wire stretching. यहाँ हम थोड़ा सा फोर्स अप्लाई कर रहे, ये थोड़ा सा स्लोली फोर्स अप्लाई करने से क्या होगा. ओके लिसन, आई एम एक्सप्लेनिंग, बिकॉज वी नीड एनर्जी इन द फॉर्म ऑफ पोटेंशियल एनर्जी, so that we adding small amount of force slowly. Guys, if we add large amount of force on this free end, then what will happen? We know that due to the large unbalanced force or unbalanced load, our wire get breaks. If we added weight as more as, then the elasticity of metal wire breaks. जब हम अनबैलेंस फोर्स अप्लाई करेंगे इस फ्री एंड को, तो हमारा वायर ब्रेक हो जाएगा. एंड due to this large applied load, our wire get breaks. If we added a weight as more as, then elastic limit of the wire get breaks. We know that if we add large unbalanced weight or force on this free end of the metal wire, our wire breaks, because when we apply unbalanced force, मतलब जब हम इलास्टिक लिमिट से भी ज्यादा फोर्स अप्लाई करेंगे उस मेटल वायर को, फ्री एंड को, तो हमारा डेफिनेटली वायर ब्रेक हो जाएगा. सो दैट वी आर एडिंग स्मॉल अमाउंट ऑफ फोर्स slowly. Okay, and due to this adding small amount of force on the free end of the metal wire, we get potential energy form. If we add unbalanced force on the free end of the metal wire, that time we will get kinetic energy. But in this case of strain energy or elastic energy, we need energy in the form of potential energy. Okay, so that here we are adding small amount of weight or load on the free end of metal wire. Are you getting this? Let's see. I am explaining again about potential energy and kinetic energy, how it is formed. See, this is a dot and this dot is nothing but our particles, and इस particles को इस पोजीशन पर जाना है, ये स्टार की पोजीशन पर पहुंचना है, एंड ये इट्स पार्टिकल्स मूविंग स्लोली 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 करते हुए वो यहाँ पहुंच रहा है इस पोजीशन पर. जब वो स्लोली स्लोली मूव कर, मतलब यहाँ पोटेंशियल एनर्जी फॉर्म हो रही है, दैट इज पी. सपोज अगेन ये हमारा पी पार्टिकल्स है एंड इस पार्टिकल्स को भी यहाँ स्टार की पोजीशन पर पहुंचना है, बट हमारे पार्टिकल्स डायरेक्टली ऐसे मूव हो रहा है विथ हाई स्पीड. दैट टाइम आवर काइनेटिक एनर्जी फॉर्म. दिस इज काइनेटिक एनर्जी. जब हम स्लोली स्लोली मूव हो रहे, स्लोली स्लोली वेट ऐड कर रहे, दैट इज आवर पोटेंशियल एनर्जी. एंड जब हम डायरेक्टली एट अ टाइम वेट ऐड कर रहे, दैट टाइम वी गेट kinetic energy. But in this case of strain energy or elastic energy, we need energy in the form of potential energy, so that we adding small amount of weight slowly slowly. Okay guys, here we adding a force F. That force is nothing but load, and when we applying a load on this free end, that means we doing something work here. It means जैसे हम इस वायर को स्लोली स्लोली लोड अप्लाई कर रहे हैं, लोड अप्लाई कर रहे हैं, तो वहाँ वायर में स्ट्रेचिंग एनर्जी फॉर्म हो रही, इसमें स्ट्रेचिंग एनर्जी फॉर्म हो रही ड्यू टू अप्लाइड फोर्स, एंड वर्क डन इन द स्ट्रेचिंग एनर्जी ड्यू टू दिस अप्लाइड फोर्स स्टोर इन द फॉर्म ऑफ पोटेंशियल एनर्जी. ओके, see carefully in this diagram. Here there is a change in length. This change in length due to this applied force. Are you getting this? Here we getting increment in the length due to this applied force F. Okay guys, you know that when we see change in length or increment in length, that time which modulus of elasticity works? Can you tell me? Okay, I will tell you. That time our Young's modulus comes in picture. We know that Young's modulus जब length increase होती है या length में बदलाव आ जाता है, that time we use Young's modulus. And we know that the formula for the Young's modulus, that is I is equal to longitudinal stress L stress divided by longitudinal strain. And guys, we know that what is the formula for the longitudinal stress? Longitudinal stress का formula हमें पता है, that is force per unit area. Similarly, formula for the longitudinal strain, that is change in length that of original length. From this previous figure, we will write the formula for the longitudinal stress and longitudinal strain. Guys, we know that longitudinal stress is nothing but force per unit area. यहाँ जो force apply किया है इस unit area पर, that is nothing but the longitudinal stress. Means longitudinal stress is equal to F by A. And that formula I have written here. See carefully. See here, longitudinal stress is equal to force per unit area. Similarly, longitudinal strain is equal to change in length. This change in length X divided by original length L. That is longitudinal strain is equal to small x divided by capital L. C. This is the longitudinal strain. Now we will put this equation A and equation B in equation number 24. After putting this equation A and B in equation number 24, we will get Young's modulus is equal to force per unit area whole divided by change in length per original length. After rearranging this term, we will get force into original length divided by area of a cross section into extension or elongation. And rearranging this equation number 25, we will get force. See this, we need to find out this force, and from rearranging this equation number 25, we will get value of force, that is Young's modulus into area of a cross section into extension x divided by original length. And this is the important formula of a force. Please note this equation in your notebook, equation number 26. Here we have find out the formula of force. Now what will be the work, or what will be the work done here? Guys, we know that the formula for the work done, that is work done is equal to force into displacement. It means W is equal to F into X, and change in work done is equal to force into change in displacement. Means here our no extension, that is X is equal to 0, and here see here our extension due to applied force, that is L. This L means X is equal to small l, that is extension. This is a lower limit, X is equal to 0, and X is equal to L, it is a upper limit. Are you getting this? Without applying a force at original length, our extension is 0 here. But when we applied slowly increasing force, that is F is equal to mg, that time we will get L elongation, and that L elongation is nothing but upper limit. So that we have taken x is equal to 0 and next x is equal to L. Guys, जैसे हमने इस फिगर में स्लोली इंक्रीजिंग स्मॉल अमाउंट ऑफ फोर्स अप्लाई किया है, उसकी वजह से जो वर्क डन हो रहा है वो स्मॉल टर्म का वर्क डन, हमें टोटल वर्क डन डिटरमाइन करना है ना, तो इसीलिए हमें इस इक्वेशन को इंटीग्रेट करना पड़ेगा ऑन बोथ साइड, बिकॉज वी नो दैट व्हेन वी एडिंग अ स्मॉल टर्म्स दैट टाइम वी डू इंटीग्रेशन. ओके ना, इंटीग्रेशन गिव्स द सक्सेसिव एडिशन सो दैट वी कैन फाइंड टोटल वर्क डन. मतलब हमने यहाँ इस फिगर में थोड़ा फोर्स अप्लाई किया था, यहाँ थोड़ा फोर्स अप्लाई किया, आफ्टर सम टाइम यहाँ थोड़ा फोर्स अप्लाई किया, एंड जितना फोर्स अप्लाई कर रहे हैं उसके करस्पॉन्डिंग हमें इंक्रीमेंट इन लेंथ मिला, यहाँ एक्स लेंथ मिला, यहाँ हमें यहाँ स्मॉल एल इंक्रीमेंट इन द लेंथ मिला. इसलिए सब टर्म्स को ऐड करने के लिए हम जो वर्क डन का मेन फार्मूला है, ये वाला फार्मूला, इसे हम बोथ साइड इंटीग्रेशन ले रहे हैं. आफ्टर टेकिंग इंटीग्रेशन on this equation, this becomes as integration dw is equal to integration from lower limit 0 to L in an integration term is f into dx. Now recently we have find that value of f. Now we will put here value of f, that is y into ax divided by L into dx, and this limit from 0 to L, and this y into a divided by capital L is the constant term. We will take on this term before the integration. See in next step. See here our work done. W is equal to Young's modulus into area of a cross section divided by original length into integration of x from 0 to L. This is our L. Now integration of x is x square by 2 from 0 to L. Now we will put this upper limit and lower limit of the integration, that is it becomes as W is equal to ya divided by L in bracket. फर्स्टली हम अपर लिमिट उसमें पुट करेंगे x की वैल्यू में, दैट इज एल स्क्वायर बाय 2, एंड फिर वी पुट लोअर लिमिट, दैट इज x इज इक्वल टू 0, इट बिकम्स 0. ओके, नेक्स्ट इट कैन बी रीअरेंज एज वर्क डन इज इक्वल टू y into a divided by L into L square by 2. This is our total work done. See, this is equation number 28 gives total work done. Please note down this equation also in your notebook. When we solve the example depending on the work done, that time this formula is full, or this formula can be written as work done is equal to हाफ कोएफिशिएंट लिया है हमने, ये जो हाफ है 1 डिवाइड बाय 2 ये स्टार्टिंग में लिया, इनटू वाई एल स्क्वायर डिवाइड बाय कैपिटल एल. और ये हम एल स्क्वायर जो है वो ऐसे भी अरेंज कर सकते हैं, एल इंटू एल, दैट इज एल स्क्वायर. ओके, यहाँ हमने ऐसे इस स्टेप में ऐसे एल स्क्वायर अरेंज किया है, मीन्स W is equal to हाफ इंटू वाई एल डिवाइड बाय कैपिटल एल मल्टीप्लाइड स्मॉल एल. ये एल ये जो स्मॉल एल है ना, मल्टीप्लाई में वो एल स्क्वायर हो जाएगा, एंड हमें वो प्रीवियस इक्वेशन में मिलेगा एज इट इज. एंड रिसेंटली वी हैव स्टडीड दैट वाई ए स्मॉल एल डिवाइड बाय कैपिटल एल इज नथिंग बट द फोर्स ना. सी हियर फोर्स वाई एक्स डिवाइड बाय कैपिटल एल, and here x is nothing but L. When we putting x is equal to L, that time YL divided by L, that is force. So that we have put it here YL divided by L is force. Put this value in above equation, in this equation, then our work done comes half into ये क्या force की value है into force into small l, and this is the equation number 29. This is a different or various form of the work done equation. ये both are same equation having different form. Guys, we know that force is equal to mg, and that force in the sense of load, so that we taken as force is equal to load, and small l is the increment in the length due to applied force, and that small l is nothing but the extension created in the length. So we will put f is equal to load and small l is equal to extension in equation number 29. Then our formula becomes half into load into extension. See here, easily we can write half into load into extension. This is an important formula, and it is equation number 30. Up to this we have completed work done, force, Young's modulus. These terms we have completed, and now we need to define strain energy. From this equation of the work done, I will define strain energy. Let's see. Work done by the stretching force or load is equal to the energy gained by the wire. This energy gained by the wire is called as strain energy, and this energy is in the form of potential energy. I will giving you a definition in better way again. Listen carefully. Strain energy is defined as an elastic potential energy gained by the wire during the elongation by stretching force. An elastic potential energy gained by wire during elongation by stretching force. That is nothing but our strain energy or इलास्टिक एनर्जी. ये जो इलास्टिक पोटेंशियल एनर्जी है ये वेरी इंपॉर्टेंट वर्ड है, प्लीज कीप इन योर माइंड. दिस इज अ पोटेंशियल एनर्जी, दिस इज इन द फॉर्म ऑफ पोटेंशियल एनर्जी. वी नो दैट यूनिट ऑफ द एनर्जी इज जूल और अर्थ. एनर्जी का यूनिट जूल भी है एंड अर्थ भी है, अनदर यूनिट. एंड फ्रॉम दिस इक्वेशन ऑफ फोर्स, इक्वेशन जो है फोर्स का, यहाँ से हम एनर्जी का डायमेंशन भी निकाल सकते हैं. और फ्रॉम द इक्वेशन ऑफ E इज इक्वल टू mc स्क्वायर, इस फार्मूले से भी हम डायमेंशन निकाल सकते हैं. एंड डायमेंशन कैसे फाइंड आउट करना, बाय यूजिंग अ यूनिट और बाय यूजिंग अ फार्मूला. आई हैव टोल्ड यू स्टार्टिंग लेक्चर ना, जैसे कि हमने फोर्स का डायमेंशन निकाला था, स्ट्रेन का, स्ट्रेस का, जो बेसिक क्वांटिटी का डायमेंशन निकाला था, उस टाइम मैंने आपको समझाया था हाउ वी विल फाइंड द डायमेंशन फॉर द गिवन क्वांटिटी और गिवन इक्वेशन बाय यूजिंग यूनिट और फार्मूला. सो by the equation of E is equal to mc square, we get dimension for energy, that is m1 L2 T minus 2. Okay, and strain energy is also called as elastic energy. Until now we have done work done, total work done, and now we are going to study work done per unit volume. Work done per unit volume is nothing but the work done in the stretching wire divided by volume. And we know that work done formula, that is half into force into extension, and volume is area into L. So rearranging this equation, it becomes as half into force divided by area into small l divided by capital L. And we know that stretch is equal to force per unit area, strain is equal to small l, that is change in length divided by original length. Put this value of stress and strain here, it becomes work done per unit volume is equal to half into a stress and a value strain. That is equation number 31. This is the equation of work done per unit volume. This is the important equation. अभी हमने work done per unit volume देखा. Now we will study strain energy per unit volume. Strain energy per unit volume का फार्मूला क्या है? Strain energy in a stretching wire divided by volume. Where strain energy in the wire is nothing but work done in stretching wire. Listen carefully. We stretching to the wire means we applying something load, and that load is nothing but the force. And when we applying a force on something body, that time there will be a something work done now. It means that stretching energy in the wire is equal to work done in the stretching wire. So put this work done in the stretching wire in this term. इस प्लेस पर इस वैल्यू को पुट करना है. Now putting this value, we will get equation of a stretch energy per unit volume, that is work done का फॉर्मूला पुट करना है हमें. Half into f into small l divided by volume, that is area into original length. After rearranging this equation, it becomes as strain energy per unit volume is equal to half into fl whole divided by area into original length. See this, हमने rearrange किया है इसको. a coefficient 1/2 as it is आया, and f divided by area and small l divided by capital L. And we know that force per unit area is stress, and change in length divided by original length, that is small l divided by capital L, is a strain. Put this stress and strain value here, it becomes stretching energy per unit volume is equal to half into stress into strain. Number 32. And this equation also write down in your notebook. And guys, here we have get stress into strain. We know that formula for the Young's modulus, that is y is equal to stress by strain. By rearranging this Young's modulus formula, we get this stress is equal to a strain left side पर जाएगा. It becomes stress is equal to Young's modulus into strain. Put this value in equation 32, it will becomes stretching energy per unit volume is equal to half into stress की value put करना है, that is y into strain into strain. It means that stretching energy per unit volume is equal to half into Young's modulus into strain square. And this is an important equation, and this equation is 33. Guys, again from this Young's modulus equation, we can tell the value of strain now. Strain is nothing but the stress by Young's modulus, and that stress value and this strain value, that is stress by Young's modulus, we will put in this equation. Let's see in next slide. Strain is equal to stress by Young's modulus, putting in equation number 32. इस equation में हमें put करना है. So let's see. Stretching energy per unit volume ये stretching energy per unit volume है, and stress as it is रखना है, stress as it is, and strain की value क्या है, stress by y. Here we have put it strain की value, that is stress by y. So our equation becomes stretching energy per unit volume is equal to half into stress square divided by Young's modulus. It means that ये जो y है Young's modulus हम यहाँ स्टार्टिंग में लेंगे 1/2 के साथ. So equation becomes stretching energy per unit volume is equal to 1 divided by 2 Young's modulus into stress square. This is equation number 42. Guys, this equation number 32, equation number 33 and last equation 34, these are the various form of strain energy. strain energy के various form है. These are the various form of strain energy per unit volume of a stretched thin uniform wire. And this strain energy is nothing but the elastic energy. Guys, in this way we have studied about strain energy or elastic energy. And in next lecture we will solve the problems depending on this article. Please wait for the next lecture. Guys, this is all about today's lecture on the elasticity topic series. You guys are genius. Keep learning, keep growing, be part of Physics Warrior by Shivkanya YouTube channel and be happy. If you like our video lectures, please watch upcoming lectures also, and also hit on the like button. Please subscribe this channel, and if possible, please share with your friends. Thank you for watching. Thank you for supporting. Thank you.